All right. Thanks all for joining us today. I'm very excited to talk about the updates we've had on our gene fusion representation project and to invite Kathy Cottrell and Karen Tsuchiya to introduce our gene fusion oncogenicity project, a new project of the VICC that's going to be kicking off, I think, sometime this month. It's really a delight to be able to report on both of these efforts, and I'm looking forward to having a good discussion about where we're at and what's coming up. That's it for the agenda. For those of you that weren't here last time, I'd just like to repeat the prior announcement that we are going to be having a VICC hackathon this year preceding the Cancer Genomics Consortium annual conference. This will be on August 12th in St. Louis. And I encourage everyone to consider joining us in St. Louis for that event.
Please come, join us.
Thanks, Wes. So I think outside of that, we don't have any other announcements, but I'll just pause here and ask my co-directors if there's anything else they'd like to add.
I don't think so.
Second the invite to St. Louis. I think the hackathon's going to be even better than last year if possible.
All right, great. Well, with that then, I suppose it's time for us to go ahead and kick off the talks. Let me go ahead and start the slideshow here and share my screen. Okay. There we are. Is everyone able to see the PowerPoint or the presentation?
We can see your email, Alex.
Yeah, we get to see your email.
That's not quite what I was going for. Hang on just a second here. All right, we'll try this one more time. How's that?
Perfect.
All right, thanks all. Okay, so let's go ahead and jump in. To begin, just a bit about gene fusion representation. This is a long-running project of the VICC. I know a number of you have been involved in this in one way or another, but for those of you that are new to the consortium or to this call, we're going to just do a brief run through of our problem scope and what we've been working on. I think many of you are aware that gene fusions have variable specificity in their notation, how they're used in the literature, how they're used in reported assays. This could be everything down from individual notation at the breakpoint level with an associated fusion inference, up through a specification of exon junctions, to the genes that are involved in the fusion itself, as well as entire families of genes or genes with multiple different partners. And across this variable specificity, there's a range of different syntaxes and nomenclatures, and it's a very confusing space. And this is, of course, in addition to some of the challenges we observe in the ambiguity of reporting of fusions. So here's the BCR-ABL1 fusion, which can be detected by a number of different messages. These are slides that were shared by Deb Ritter and Sharon Plon on a number of different techniques they use for detecting gene fusions involving whole genome sequencing, shown at the bottom, as well as by FISH probes in the top right. And notably, these different ways of representing fusions can cause different ways of interpreting what you've actually observed or inferred, and whether or not this corresponds to an actual direct detection methodology like RNA-seq or RT-PCR, or if it's something that's inferred by whole genome sequencing or cytogenomic assay, is something that is a kind of an ongoing ambiguity in the field. In addition, there's the challenge of how fusions are represented in knowledge bases like CIVIC. So here's the BCR-ABL fusion variant. And what you can see is in CIVIC, they provide representative coordinates for what this fusion is. And if you read through the text, you can find additional information about it, that it involves the ABL kinase domain, as one of the key features of this fusion, but which it's not part of the formal structured representation of this fusion event. And depending on what resource you're looking at, seeing a simple gene A, gene B fusion may indicate a number of different things. It can be a common dominant isoform among a possible set of fusions. It can be a fairly arbitrary representation of a diverse set, or it can even be just a gene level shorthand for a specific fusion that occurs at those coordinates. And in some cases, like in CIVIC, additional context about the concept, what the concept represents, might be provided as a component of the free text descriptions we just saw with ALK kinases. So, trying to then get to the point where we can represent these in a reproducible and interoperable format across resources is a primary goal of this work. And there have been some recent advances in other groups in gene fusion representation, which I'd like to briefly cover. Most notably, the HGNC, the Hugo Gene Nomenclature Committee, came out with this recommendation for a new nomenclature to describe gene fusions. And this is in late 2021, early 2022. Where they created a new double colon syntax that they felt was aligned across a variety of specifications and formats for representing gene symbol 1 to gene symbol 2 rearrangement associated with the gene fusion. And they found that it aligned with a number of different communities, including the ISCN guidelines for genomic rearrangements, the HGVS nomenclature for fusion transcripts, and guidelines for gene fusions in other organisms, such as Stolfi et al. In Genesis 2015. But they also, this new syntax doesn't address a number of ongoing challenges in the field for representing gene fusions. This includes no option for using stable gene identifiers within the syntax, no differentiation between what we call regulatory and chimeric transcript fusions, nor a differentiation between chromosomal rearrangements and gene fusions, which are used interchangeably in the recommendations paper. And so in order to work on kind of disambiguating and defining these various concepts and creating a nomenclature and information model that allowed us to be precise about what fusions are, we had a collaborative activity between members of the VICC, as well as the QuinGen Somatic Cancer Working Group, the Cancer Genomics Consortium, and the CAP and ACMG Cytogenetics Committee. And between us, we worked on 4 primary goals. First, a terminology that allowed us to define and disambiguate gene fusions. And specifically, we looked at how do gene fusions differ from the driving events that cause them, such as rearrangements, read-through events, and trans-splicing. Defining both regulatory and chimeric transcript gene fusions as separable classes of fusion events, and also disambiguating between fusions detected by assay or assay gene fusions and categorical fusions that you typically see when describing fusions in aggregate, such as in knowledge bases or biomedical literature. In addition, we wanted to create a minimum information model that allowed us to characterize gene fusions for representation in database systems. This gives us the salient elements for different types, specificity, and context of gene fusions. And the emphasis in this effort was on completeness and semantic precision. And then finally, we use these components to develop a nomenclature that can be used to describe gene fusions. And we're going to spend most of this talk using the nomenclature to kind of illustrate these different classes of fusion events. Finally, we also spent some effort working on workflows and tools to enable people to represent fusions in a variety of different contexts. So the specification itself sits at fusions.cancervariants.org. Here's the homepage. You can go there and you can check it out. And as you can see, all of these components we just discussed are present in the sidebar here. We have our information model, our terminology, our nomenclature, a workflow, and supporting tools. We also have a notion of community feedback and endorsements, and we're going to get into some of the work we've been doing to align this with other community groups towards the end of this talk. So to begin, just a little bit about our terminology. What is a gene fusion? So a gene fusion is really one of 2 different classes of fusion events. There's the, I would call it like historical or canonical gene fusion, which is the joining of 2 or more genes resulting in a chimeric transcript. But then there's also this broad class of fusions we call regulatory fusions, where there's a novel interaction between a rearranged regulatory element with the expressed product of a partner gene. And you can see examples of regulatory fusions up here at the top of the slide. We see there are promoter swap fusions and enhancer-driven fusions as 2 very common types of regulatory fusion events that we see as relevant in clinical application. We also wanted to kind of differentiate gene fusions from things that are very similar to them. So gene fusions, for example, are driven by, but are distinct from rearrangements. And therefore fusions can be inferred from DNA assays, and this information is captured in both the information model and our nomenclature. Importantly, the following classes of variation are not fusions. This includes internal tandem duplication, as well as loss of gene expression by rearrangement. Okay, so let's talk about kind of the gene level nomenclature for fusions. So I think everyone's familiar with the representation of fusions as two gene symbols separated by a double colon. These are the recommendations that came out from Bruford et al. By the HGNC. What we've done in this specification is we provided an optional syntax that allows people to also include HGNC identifiers. The HGNC does recommend use of identifiers elsewhere in a document or a manuscript where you're describing a fusion. So you'd have, say, BCR-ABL1 as the fusion representation. Then elsewhere, you might have BCR HGNC 1014, and then ABL1 HGNC 76. However, there are some applications where we think it might be beneficial to be able to put this into the nomenclature itself. So we provided the ability for people to do that using this parenthetical syntax. We've also decided to provide a way of annotating when a fusion event is inferred. So for example, when you see BCR-ABL1 fusions in the context of some cancers, you might say, okay, well, based off the rearrangement associated with the chromosomal regions of these genes, we're inferring the presence of a BCR-ABL1 fusion, and you can represent that using this parenthetical nomenclature around the double colon break. We also talk about how we can detect unknown partner fusions. So here we see an ALK break apart assay where the two halves of the ALK gene are broken apart, resulting in this red dot and this green dot here. And in that case, the inference is that this ALK partner has bound to another gene, and that you have an ALK fusion, and you can target it with an ALK inhibitor. And that's all you really need to know, but you need to be able to report it. So we use this unknown partner as well as that inferred fusion syntax in order to say, okay, we've inferred a fusion of ALK with a partner. We want to report on that. Here's how you can do it at the gene level. This is a distinction that we're making to multiple partner fusions. So one of the things that we often see in the literature or in professional society recommendation is the notion that a particular gene, here KMT2A, may have multiple known partners. And it's not that you've done an assay and you don't know what the partner is, but rather you know that this gene is promiscuous and has a number of different fusion partners that it can join with. And the way this is used in WHO classification is with this V syntax for rearrangements. And so we've reused the syntax to also allow us to do multiple partner expression in our gene fusion nomenclature. And that represents, as said here, any of a large number of fusion partners. Finally, we've had to extend the gene fusion syntax to also include a regulatory nomenclature. So the idea here is that when you have regulatory fusions, it's not actually the expressed gene product of one of the partner genes that you're discussing. It's the associated regulatory elements. And there's no way of disambiguating those regulatory elements from the expressed transcripts of that gene, or at least there wasn't. And so one of the things we did is we worked on this nomenclature that allows to express exactly what you're talking about. So here, for example, we see an enhancer element associated with the IGH gene locus as specified by this reg_e at IGH syntax. And so this lets us say that we're having IGH MYC fusions that don't actually involve the IGH transcript, but instead uses the super enhancer complex near the IGH gene. Okay, so now we're going to move on to sequence level fusion. So up until now, we've only been talking about kind of this gene level description. This is what we see in the HGNC nomenclature and where we've seen those extensions as needed to cover those use cases. Here, we're going to get into how you actually describe fusions at the sequence level. For this, we use a novel exon-based transcript segment nomenclature. So this allows us to represent exons of transcripts in a compact shorthand. And this is a key feature that we think accurately or more precisely represents the nature of clinical reporting today, where people tend to talk about the junction events in terms of the exons from each transcript that are associated with it. And here we're saying that we basically see, for example, the entirety of exons 1 through 7 for this EWSR1 transcript merged to a linker sequence of the novel sequence that's been introduced into the fusion. And then from there into the FLI1 exons 3 to 9. And that provides the structure for this overall chimeric transcript sequence. We also have another shorthand that we think accurately reflects how these are typically assayed, where you see not the entirety of the transcript, but rather just where those junction boundaries are. So here we say there's a junction boundary at exon 7 from EWSR1, again, that linker sequence, and then a junction boundary at exon 3 of the FLI1 transcript. And this distinction is saying basically we're not certain that it actually extends out to any degree beyond this junction that we're reporting. And this is a little more reflective of many of the assays that are in use today. Finally, the nomenclature does support offsets. This is an HGVS-like syntax where we basically allow us to say at a given exon boundary, you can offset into the intronic or exonic space as necessary if a fusion event includes sequence at a position that's not at that junction boundary. So here we see, for example, a +2 offset both on the 3' or the 5' and the 3' transcript segments for this chimeric transcript. Okay, so the other thing we built is an information model.
Can I ask a question about that last slide?
Absolutely.
So one question I had was, what does it look like if there is no linker, like if it's a clean connection without adding any novel sequence?
Yeah, so basically this linker sequence it's kind of been appended in here with an additional double colon. You can imagine omitting this entirely. So there would be no ACTT, AGATA double colon. It would just be directly from here, from the end of this double colon, directly to this NM_002. The idea here is you can piece together multiple different components as an expressive set of junctions of sequences or transcript segments or other entities that are used. And I'll show you what those other entities might look like in a second here.
And the +2 and +5, okay, so that's like plus is like going to the right into the exon in one case and into the intron in the other case.
That's right.
And does doing it this way take precedence over having a linker sequence? Because like you could have, say, 2 bases that match the intron, but you don't actually know for sure whether they were like inserted or the intron sequence. So would, like, if it could be either way, would the preference be to describe it as an extension of the existing sequence rather than to describe it as a novel linker sequence?
That's right. Yes. So if it looks like it's a continuation into the intronic space, for example, and it matches that sequence, that's how you'd want to represent it, as an offset, not as some unknown linker sequence.
Cool. Yeah, makes sense. Thank you.
Yeah, no problem. And another thing to say about this is that linker sequences and transcript segments were shown here in terms of how we structure these chimeric transcript events. But another component that we can sometimes use is a templated linker. So here you have basically a novel sequence that's not part of a known transcript, say a cryptic exon that exists somewhere in the intervening space, and you want to represent that using the coordinates from which that sequence was derived. You can do that using the templated linker objects, which would also fit inside be bounded by these double colon separators. So you could add in any of these components as necessary to describe the sequence of your chimeric transcript. In addition, one of the things that is captured in the information model, though not reflected in the nomenclature, is the notion of all the genomic locations associated with each of these events. So if you have a transcript segment with a boundary at this position, the other thing you'll be storing in the information model is where the aligned genomic coordinate is for this. And this is for long-term data fidelity. As annotations change, get updated, knowing kind of where this is aligned to and how that was detected is an important way of being able to reproduce these analyses and reinterpret them down the road. And while it's not reflected in the nomenclature, it is something that we try and capture in the database systems and data objects associated with these records. The other thing that we're capturing in our information model are elements specific to the two primary contexts under which we evaluate gene fusions. So categorical fusions, again, these are the types that you'll see in the biomedical literature or in databases, have additional properties associated with them regarding functional domains as well as reading frame. And these additional pieces of information are critical to the evaluation of whether or not an assayed fusion matches this piece of knowledge, but they're typically not captured in fusion database systems today. So this is one of the recommendations we have, is basically to get to this point where we're able to characterize structurally whether or not there are functional domains when, if preserved or if lost, are critical to the designation of a gene fusion. Similarly, whether or not a reading frame needs to be preserved in the context of a gene fusion is another piece of data that is associated with categorical fusion curations. On the flip side, for assayed fusions, these are the types that are detected by assays. There are data associated with the assay itself. So one of the things that we need to capture is, what is the assay, both in terms of a human readable name, as well as some sort of structured representation of the assay type. And this is what's going to allow groups to be able to determine how a fusion was detected and inferred, which has important implications for how you might match it to genomic knowledge or the level of confidence you might give to it in terms of clinical assessment. Similarly, the causative event, whether it's a rearrangement-based, it's part of a reference-based read-through event, or if a trans-splicing fusion, is something that we want to capture alongside the actual fusion itself. So this is an element that's unique to assayed fusions. Okay, so now that we have these recommendations, I want to talk a bit about how we've been working to engage with the community and align across consortia. So we first released our community draft as a product of this group in Q2 of last year. And we've kind of had an open period. We went and we presented at the CGC and the ClinGen, describing this work, gathering feedback from the broader community, and making sure that our work was in alignment with their thoughts. In addition, in July of last year, we began an alignment process with HUGO. This is across the HGNC, HGVS, and ISCN committees. We are literally a day away from having our current draft accepted into HGVS. And so while I won't be able to show you this live on the site, know that it's coming very soon. And I do have some drafts to show you from the open pull request, which we'll get to in a minute. Following our alignment, following completion of our alignment with HUGO, our next step is to then put all this down to a preprint. We've started working on this over the last year or so, and the idea here is to take our work from the nomenclature alignment, update that work, and then submit the preprint sometime either late this month or maybe towards the mid or late April timeframe. And then from there, of course, we're aiming to submit this for publication and revision, which will take place throughout the year. So that's kind of our roadmap for where we're going and how we've been aligning with the community. We're pretty much wrapping up at this point. And like I promised, we've been working with HUGO and HGNC and ISCN and the HVNC to kind of orient the VICC recommendations around the current guidelines from those groups. And while HGNC and ISCN don't have any formal published guidelines, that were kind of putting the VICC specification into at this time, we did align with their existing recommendations. For HGVS and sequence representation of gene fusions, we do have an upcoming set of changes, and there are three primary changes that are happening in HGVS in response to this work. First, our terminology is going to be incorporated into the HGVS glossary. And so what I mean by that is if you go to the HGVS glossary page, here you'll see things like our definition of regulatory fusion that are going to exist on this page, as well as chimeric transcript, read-through transcript, gene fusion, et cetera. All of our definitions allow us to disambiguate these concepts will be part of the HGVS glossary. The second thing that will be happening is the specification itself will be recommended for the description of gene fusions in HGVS. So what that looks like here on their general page, you'll see this new bullet where they basically say HGVS recommends following the HGNC guidelines and the VICC gene fusion specification to describe products of gene fusions. And then it outlines what these recommendations are, starting with the HGNC recommendations for the syntax and following up with our terminology, information model, and nomenclature for gene and exon level representation. And then finally, HGVS also recommends the use of adjoined transcript segments, which is also adopted from our specification and our alignment work. And that's going to be basically an update on this page where it used to say fusion transcripts. These are now going to be called adjoined transcript segments based on their alignment with us on this work. These are all upcoming. Like I said, there's an open pull request. It's been reviewed and approved by most of the HVNC, and I think there are just a few people that might be reviewing yet today before we bring this into HGVS formally. So that's where we're sitting. And then finally, just a note about a few supporting tools. For those of you that are interested in kind of the data representation of gene fusions, we've built this Fuser application that it's a Python-based library that allows for the construction of gene fusion data structures. It includes validation and nomenclature translation built into it. We also have a neat little UI tool built by a few members from the Wagner lab that has focused on how we can basically do a drag and drop type interface for building gene fusions. This is there's a beta version live over here at fusion-builder.cancervariants.org. You can check it out. We've got assay fusions and categorical fusions, and it allows you to basically just do kind of like drag and drop representation of fusions. So we can have like our favorite BCR ABL1 fusions, and you can just kind of build them on the fly. And you can use that to then, and you can go through all the different, elements needed for the representation of fusions in the categorical or in the assayed sense. For example, is there a reading frame that's expected to be preserved, et cetera. There are a few demonstrations here, so we can see like what ALK fusions look like. You can see a summary of it, both in terms of the nomenclature as well as what the computational representation looks like. So I'd encourage people to check it out if you want to try figuring out how to build some of these gene fusions and see what it looks like when applied to the nomenclature. And that's kind of where that's at. And then finally, just an acknowledgement for all the various people. This is an incomplete list. A number of people has just grown over time, but we've had quite a few participants from many sectors of academia, industry, and government associated with the work, and it's really a privilege to work with everyone who's been contributing to this. Of course, I have to thank the NHGRI for their support of this project through these awards, as well as Gordana Rasa, who's been the kind of primary champion of this work and has been the primary supporter of this throughout the process. And with that, I am happy to take any questions. This link doesn't work yet. I didn't set that up, but at some point I will set this up so you can go to this slide deck at VICC-fusions23. But I'm happy to take any questions at this time.
Super cool, Alex. I'm so impressed with all the work you guys have done on this. I had just like one small technical question and then more of a broad question. It looked like you were able to actually directly edit the HGVS like nomenclature pages. They basically allow you to spin up your own development version of that and test out changes to it? Is that publicly accessible, or I mean,
yes, yes. So
cool. That's
there
great.
are two things. There are two things to mention there. The first is that for a long time, Varnomen has had a somewhat hidden GitHub repository that is open, public, where you can make these types of changes. And the pull request for this work exists at the current repo. So this is at the HGVS nomenclature org, Varnomen. This is the GitHub pages site associated with the HGVS nomenclature. And you can see the open pull requests and the changes that are upcoming for this fusion alignment work. But I should also mention that we're trying to modernize this. So the current build process is somewhat kludgy, relying on GitHub pages. We're moving to a make docs and read the docs oriented architecture. So there's an upcoming rework, and then we as a committee will be kind of writing that up and and publishing on the new framework that's going to allow for better community engagement down the road. So it's something I'm very excited about, but it's not, like I wouldn't go making pull requests at Bar-Nomen right now, because we are probably a month or two out from transitioning over to a new repo where this revised architecture will be.
That's really cool. It's like the future is now, right? Like you think of the past where this sort of like HGNC nomenclature, HGVS type stuff would all happen in like closed door meetings on paper. And now we're making pull requests to markdown style pages. And yeah, fantastic. I really think the tools you guys are building and the fact these recommendations are being incorporated into the HGVS pages are going to help a lot with uptake, but still it's like a big education task to get people to think about representing fusions in this much more sophisticated way. So what are your plans for getting the word out and basically educating the masses?
Yeah, those are good questions. I mean, the web presence is basically the start. So of course, all of this is open on our Fusions page, fusions.cancervariants.org. And the idea here is to provide all the documentation in an open and living form where people can kind of see where things are at, how things interrelate, et cetera. But then the second question is, kind of how do we get this in front of people's eyes? And I think the answer there is just to continue to try to work towards presentation of this material at workshops and at conferences. The other thing that we're going to be working on, I think, is an educational video series. And I think, that's primarily going to be Wes Gore on the call here, who's going to be helping us run that effort. So those are some of the primary venues for educational efforts that we were thinking about. But if you have suggestions, we're certainly open to it. Like we're always looking for ways to better educate people on the complexities of gene fusions and how we kind of represent them across this framework.
Alex, we need to get you onto AMP as well.
Absolutely.
That's a good it's a good audience for this work.
Okay, should I reach out to Barbara and suggest something?
Yeah.
Oh, okay, I'll do that. I'll send her an email.
Now, obviously, we can cross promote this through CGC as well. If you have ideas about how to represent it on and link to relevant materials or promote videos, just let us know at the communication committee.
Fantastic. Taking notes.
Great work, Alex. Thanks for sharing this. And maybe an extension of Obi's question. I'm thinking about clinical reporting and ordering physicians who may or may not have an appetite for some of the more complicated syntaxes or representations. Is there a sort of a stage or tiered representation that here's the thing that everybody will understand, and then here's the specifics or the details of that precise breakpoint or joined domains or exons that are part of the recommendation?
Absolutely. Yeah. And yeah, we recognize this is a reality of clinical reporting. And I think a lot of people, to start at the most generic level, which is kind of the gene to gene fusion syntax, which is of course very simple, right? That's like things like, well, that's a bad example, but BCR-ABL1 here as like kind of the most basic unit of representing a fusion. And if you wanted to get more into sequence level reporting, but still keep it simple, that's the idea behind the exon-based nomenclature we've developed. It really is an effort to try and kind of get the precision of what's actually happening at the sequence level to a point where it's still readable and interpretable by, the non-genomics professional.
Yeah, I would agree with that pretty strongly, that so many physicians would look at something like what you're, with a lot of detail and not be able to recognize, all right, is it an EML4 ALK fusion or not?
Absolutely. And so one of the things that we've done actually in our syntax here is we've added these gene annotations that exist alongside the sequence identifiers. The identifiers themselves, of course, are important for what exactly does exon 7 mean, because as you know, you can have multiple different transcripts associated with the gene. But the idea here is to basically say, okay, we're talking about EWSR1 exons 1 to 7, FLY1 exon 6 to 9. And one of the things that we do actually, which I didn't really get to in my talk, we do have this notion of utilities that helps people understand kind of what are the commonly used or preferred sequences for different genes. So an example here, if we go to ALK, you can see here's the ALK gene or some information about it. Then here's the main select representation. So main is the matched annotation between ensemble and NCBI, or vice versa. And this is a set of transcripts that have basically been like deemed as the primary representative for a given gene symbol. And so what we do is we provide this utility here to allow people to say, okay, I've got a gene, what symbol am I supposed to use there again? Like you can go here and you can look it up. And so we have both RefSeq and ensemble transcripts associated with it, as well as the corresponding protein changes. So that's the idea behind these utilities, is to basically help people get to that point without worrying too much about memorizing the numbers of the transcript sequences themselves.
Yeah, I think it's great to have the standardized way to communicate, so we all know what we're saying and we have a standard way to communicate that, but to also have the flexibility in a clinical report to be able to say EML4 ALK, and that, just if that's what it is, that's what we're reporting, it's actionable, so that it's not confusing.
Absolutely.
Great, thank you. Agreed.
Thanks for the comments, Andy and Cheryl. All right, well, I recognize that it's 11:40 and I think I've consumed more than my fair share of time. So at this point, I'd like to turn over the floor to Kathy Cottrell and Karen Tsuchiya, who are going to lead us in their upcoming work on gene fusion oncogenicity. I'm going to stop sharing my screen. The floor is yours.
Great, I will go ahead and share my screen. All right, I think everyone should be able to see this now, and thank you all so much for allowing Karen and I to speak this morning about the VICC Fusion Oncogenicity Project. So I'll give a little bit of background about this initially, defining what this project does not encompass. So we know that there was a fantastic publication in 2022 in Genetics and Medicine that specifically came out regarding the classification of oncogenicity of somatic variants. And this was put forth by ClinGen, CGC, and the VICC in terms of an SOP. And this framework really mimics a lot of what we saw in the ACMG AMP guidelines for the interpretation of germline sequence variation. Notably, within that publication, that SOP was specifically not intended for the classification of oncogenicity of fusions. And so that allows a space and additional projects to be able to define that out more fully. I will not belabor speaking on this because Alex gave us a really fantastic update about the current work going on with the ClinGen CGC VICC gene fusion characterization project. And so as Alex just presented, that was really focused on terminology. There was discussion of a minimal information model, some nomenclature, and of course the fantastic tools that he showed. And so this intentionally excludes guidance on classification of fusions. So this gets us to our current project, which Karen and I are kicking off this month. And so we know that the breadth of clinical fusion testing is expanding, whether this is through large fusion panels or whole transcriptome analysis. And so we know that there is going to be an increasing spectrum of detectable fusion events that are occurring, including novel fusion events. And so there's been a lot of desire to have a framework to help lend some evidence towards classifying the oncogenicity of these events in relation to disease. And so really the aim of this project is to develop some systematic recommendations and procedures for the classification of gene fusion pathogenicity or oncogenicity in cancer. And just to give you a few examples of what that might look like, we're thinking about what are the function of those partner genes. I'm thinking about orientation. Does the product maintain frame, for instance? Would it be absent in normal tissues, or is it observed at some frequency? I'm also thinking about functional studies, but these are all really pieces of the evidence framework that this work group will be focused on developing out. I will let Karen take it from here.
Thank you, Kathy. I'm very honored and excited to be co-leading this work group with Kathy. we have already assembled a work group for this project, and this map of the world emphasizes the international representation of the work group. The stars show the location of different work group members, in addition to members from across the United States. We also have representation from South America, from Europe, and from Australia. So Kathy, you can advance to the next slide. So in terms of the work group individuals themselves, Kathy and I are co-leading this project, and I just wanted to mention that I'm currently at University of Washington in Seattle, but my excellent colleagues at Nationwide Children's convinced me that I needed to join them, so I will be doing that in a few months. So Kathy and I are primarily responsible for the oversight and deliverables of this project. We will be setting the agenda and leading the project meetings, which we are in the process of scheduling. And we will also be leading the drafting and editing of any project documents that will include a manuscript resulting from standards for determining oncogenicity of gene fusions. And Kathy and I are also primarily responsible for communicating with other professional societies to avoid discrepancies in standards and guidelines for determining oncogenicity of gene fusions, and also to ensure that we don't have redundancy of effort between other professional societies. There's an advisory committee for this project that consists of Yasmina Kari at Nationwide, Gordana Rasa at Children's Hospital of LA, and Alex Wagner. And the advisory committee is providing advice and input to Kathy and I, and generally making sure that Kathy and I stay on task and don't take this project off the rails. We have a project coordinator, Wes Gore, at Nationwide, and Wes is currently in the process of developing a web page for this project that will house all information and documents that are developed from the project. Wes is also helping to schedule meetings, take meeting minutes, and distribute information. In terms of the work group members themselves, we try to gather individuals who have a diversity of background and experience. So some of these individuals have more of a research focus, some have more of a clinical focus, some work group members have particular expertise with hematologic disorders, others with solid tumors and different types of solid tumors. So we tried to select different people with to gather that diversity of expertise. So we have Julia Bridge, who is currently at ProPath. She spent most of her career at University of Nebraska, and she still has a partial appointment there. There's also Paulo Camprager at Albert Einstein Hospital in Sao Paulo, Brazil. And I know Paulo is on the call, so if I didn't pronounce your name correctly, please let me know.
That was perfect.
Oh, great. There's also Claire who is a lab director at Nationwide Children's. Valentina Nardi, who's at she's a lab director at Mass General Hospital and has an appointment at Harvard Medical School. There's Vera Paulson, who's a lab director at University of Washington. Angshumoy Roy at Texas Children's Hospital. And Angshumoy also brings with him some expertise in bioinformatics as well. There's Albrecht Stenzinger at University Hospital in Heidelberg, Germany. And also Deborah White, who's at University of Adelaide and the South Australian Health and Medical Research Institute. So I think we're ready for the next slide. In terms of project deliverables, even though this is a closed panel work group, We do want to emphasize that we're going to do everything possible to provide community outreach. So we plan on having periodic updates during these VICC general calls. And we also plan on having town hall meetings where we can provide updates on the progress of this project and also get input from other members. And again, we are also seeking engagement from a number of other professional societies. And the main project deliverable will be a manuscript that describes standards and guidelines for determining the oncogenicity of gene fusions. And we envision this being somewhat analogous to the standards for determination of pathogenicity of somatic variants in cancer. And I believe that is it. So Kathy and I wanted to thank everyone, and we can answer any questions that people might have.
I'm sorry if you said
More
this.
comment.
Oh, go
Sorry,
ahead.
yeah, this is just a comment, not a question. Just want to commend you on taking this on. I think it's a very, very important project, very badly needed to have real oncogenicity rules for fusions. We started transcriptome-based assay for fusions and had to come up with some criteria, and it was difficult because there's no standards out there. Also in NTRK VSAP in ClinGen, where we are supposed to develop rules for evaluating clinical significance, we had to backtrack and start from rules for oncogenicity because there is nothing out there. So really need to have this standardized. I think it's a great and important project.
Gordana, you were kind of alluding to what my question was about, which is, I was kind of just curious how the work that the NTRK VSAP has done was used to inform the development of more generalized guidelines for fusion oncogenicity, like how well, and I guess Gordana and Angshuai and many others are involved in both efforts. So how well do you feel like this will sort of work for NTRK and then for other fusions more broadly?
Yeah, I can let Karen and Kathy take the question, but my brief comment would be that some of the stuff that we had to develop for NTRK just because there were no rules out there will be applicable, but of course this project will really expand on it and make it more general.
Yeah, I would echo that. I think we are familiar with the NTRK work that is going on. I think it will be very complementary. Hopefully we can build off of that work that is already in existence. And then certainly with the goal of making it applicable to fusion events in a broader sense.
All right, if there are no further questions, I think at this point we can thank our speakers. Thank you, Kathy and Karen, for joining us and presenting on your exciting upcoming project. We'll be convening again at our VICC General Call in 2 weeks. I think the speaker is still to be confirmed, but we have somebody on the line. So we'll send out more details a little closer to. We look forward to seeing many of you back again at that time. Thanks all, and have a great week. Bye.
Thank you so much. It was awesome.
Bye-bye.
Everyone, fantastic.